We're given four relations here, and what we want to do is determine if the relation determines a function, if it names a function, and also write the domain and the range. Now, a function does this. A function takes one input and maps it over to exactly one output. Not two or three, but just exactly one. One input goes to only one output. So let's look at the first one here. What about number 1? 1 goes to 2. Nowhere else. 3 goes to 4. I don't see 3 going anywhere else. 3 goes only to 4. 5 goes only to 6. Nowhere else. 7 goes only to 8. So I'm going to say number 1 is a function. I'm going to abbreviate it here. How about fn? Now here's the domain. The domain, this is the set of input values. Now the input values are the first components, 1, 3, 5, and 7. Those are the input values. That's our domain, 1, 3, 5, 7. And the range, that's the set of output values. So what are our output values? Those are the second components, 2, 4, 6, and 8. So 2, 4, 6, and 8. So there's problem number 1. Let's go to 3. Now 3, what happens here? Is it a function or is it not? 1 go, what does 2 go? 2 goes to 5 only. How do I know? I just looked over here. I didn't see any other 2's in the first position. So 2 goes only to 5. 3 goes only to 4, right? I don't see 3 in any other first positions. 1 goes only to 4. I don't see 1 in any other first position. And 0 goes only to 6. So I'm going to claim that number 2 is also a function. And the domain, right, this is a set of first components. It doesn't matter what order they come in. How about 2, 3, 1, 0? 2, what is that? 2, 3, 1, 0. Or if you like, you could write that as 0, 1, 2, 3, right? It's a set. Order doesn't really matter. And the range, set of second components. How about 5, 4, 4, 6? So I'm going to write it as 5, 4, 6. Now that 4 appears twice. I don't need to write it in the range twice. It's a set. So what are the outputs? Well, the outputs are 5, 4, and 6. If you take any one of these values, where does it go? It goes to a 5, a 4, or a 6. And in problem number 5, is this or is it not a function? Well, look, A goes only to 3. B goes only to 4. You know, when you're looking through something like this, look at the first components. If you see a first component appearing only once, every time it's going to be a function. If you see a first component appearing more than once, like look down here at number 7, A goes to 1, A goes to 2. All right, so A goes to more than one output. But in this case, each first component goes to exactly one second component. So each input goes to only one output. So we're going to claim that this is a function. And the domain is going to be all the first elements. So it's going to be, what are the first elements? A, B, C, and D. And the domain, the range, how about 3, 4, now, I've already got the 3, right? I've got 3, 4, 3. I don't need to write the 3 again, but I will write the 5. And in number 6, this one is not a function because if you look, that first component appears more than once. So A is getting mapped. You know, I'll draw a little picture. Where does A go? Oh, that's no good. Let's try this. A goes where? It goes to 1. It goes to 2. Oh, look at this. It also goes to 3, and it also goes to 4. So if you choose A, it's ambiguous as to where it gets mapped. You don't know if it goes to 1, 2, 3, or 4. So in this case, this is not a function. But it still has a domain. It's a relation. And the domain is a set of first elements, which is just A, and the range, all right, the range is the set of second elements, 1, 2, 3, and 4.